Okay, so we've seen in the past that sometimes there are instances where we want to be able to convert something from one data type to another data type. What we've seen so far, for instance, is converting something from a string to, or I'm sorry, from a character to a string, or from a number to a string. We did some of this in class where we used the concatenation operator of strings in order to take something that's not a string and convert it to a string, right? So we've seen things like if we wanted to start with a character C, and we're using our char@, function, which is a string operator, and we're saying we want the 0th index, which again would be this r right here, and we were storing it in that variable C. If we printed this, we would just simply get r right now, right? We're storing basically r in the character variable C, and then we're printing C right here. If I run this, nothing super exciting. We'll see that we get r. But if we wanted to be able to do a string operation, suppose we wanted to convert this to a lowercase r, something that we've done in the past is we say we can use this concatenation operator of strings, and essentially what we do here is we turn C into C, right? So character is where we started with this function right here, the string operator right here. We're taking C, we're concatenating it with an empty string. Whenever we concatenate anything with a string, we're going to get a string version of that, whatever we concatenated. And so essentially what we've done is we've taken C and we've turned it into from a character to a string. If we run this right now, we don't see anything different, right? We're still going to get capital R. But if we do this, we now have the ability to do basically additional string operators onto whatever value we got up here that originally started as a C. We converted to a string, and now we can use other string operators to manipulate that variable, right? So now we'll get our lowercase r. As you can imagine, you probably want to do this in a lot of different ways. If we started with something numeric as a string, we'll say s1 equals 100, and suppose that we wanted to add 50 to s1. That was our goal, right? Well, if we did something like s1 plus 50, what do you all think we will get? We won't get 150, right? We're going to get the concatenated value. So we're going to get 100, which was then concatenated with 50. The data type here is a string of s1. The data type here of 50 is a constant or a literal 50. And so whenever we have a string variable and we use the plus operator, which is concatenation, we're simply concatenating these two things together. We're not doing any math whatsoever. So what we need to be able to do is we need to be able to convert this string into a number in order to do math with it. The easiest way to do that, or that actually, you know what, we're going to probably talk about two methods. We're going to do s2 as well, set ourselves up. So if we have s2 is 0.99 or whatever, there's two methods that we want to do, or two things that we want to do. First thing we want to do is we want to try to take s1, which currently is a string variable or string literal of 100, and we want to convert it to the number 100. We also want to take s2, and instead of being a string version of 0.99, we want to make it actual 0.99, the double value. There's two different methods, or well, one method for each that we're going to use. Case matters, so integer.parseInt, and then the string value would do it. And in this case, if we wanted to do doubles, double.parseDouble. If we do something like that, basically what's going to happen in this line of code is it's going to take whatever string you put in the parentheses here, whatever string you give it, and it's going to convert it from a string to a number. So if we started with string 100, we ran this code, basically we would be turning 100 the string into 100 the number so that we could then do math with it. Same is going on right here, right? Double.parseDouble, we give it a string, it's going to convert it to a double. So if we did something like this, and let's just start with a simple one, right? Say n1 for number 1, and we said, I'll just copy this over. Now we could do something like n1 plus 50, and you'll see that we get 150, right? What's happening here is that we started with string value of 100. You saw before, if I left that print statement in there where it was s1 for string 1, we would get two different values, right? If I run this again, the first value is going to be concatenation going on because s1 is still a string. The second value is going to be the actual sum of the two numbers because we converted that string s1 right here into number n1, and then we added n1 plus 50. The exact same thing works for doubles, right? We could do double d1 equals double dot parse double and pass it the variable s2. So s, if I could spell double. Right. If we run this, this is with s1 as a string. This is with n1 as an integer version of s1. And then d1 right here, we converted what was stored in s2, which was 0.99. We parsed it into a double value, so it's no longer a string value when this executes. And we can store that value into d1, which is a double data type. And then when we do d1 plus 50, we get 50.99. So very, very simply, this is the easiest way to convert between strings, and at least for these two data types, integers and doubles. You can do it with other things like dates, for instance. Sometimes you might have a date literal, string literal, that you want to convert to a date object so that you can add days or take away years or whatever. Those methods exist as well. So Java gives you ways to go between data types. Some are used more prevalently than others. But before I wrap this up, I mean, this is really this simple. This is really, really this simple. For the context of your assignment, I thought it would be good to go ahead and put together a little program that would allow us to use converting numbers much like you would do it in your assignment this week. So the first thing I want to do is I want to get input from a user, and then we're going to convert that input into a number and then do some math with it, okay? So if you recall from previous videos, if we're going to get input from a user, we need to import a certain input-output package called java.io. We also need to put any code where we are going to get input from the user, into a try-catch block. We've done this as well, if you did the videos in order for this week. All right. We need a Bufferedreader object. I always call it n. You can call it whatever you want to. Right? And this is going to give us the ability, in our previous video, this is going to give us, we don't care how this works, understand why it works, it just works. But this is going to give us the ability to get input from the user, right? So suppose I want to get an integer from the user because I want to add two numbers. First I have to do is tell the user what I want, right? Print. Please type an integer. All right. The next thing I need to do is save whatever the user types, right? So we'll say int number1 equals n.readLine, right? If you recall, or actually let's stop here. This is going to fail, right? Why is this going to fail? N1 is not a number, or I'm sorry, N1 is not going to be read in as a number automatically, right? It's going to come in as a string. We're trying to take a string here and we're trying to store it inside of an integer variable. Obviously that's not going to work. For this part of it, I'm going to show a really kind of arduous step-by-step way to do this. So let's cheat a little bit. The next time I do this, I'll show you a little bit of a shorter way to do this. So let's call this S1. You notice I just changed the data type from integer to string, which works now because this is going to give us a string. We can only put strings in string variables, right? We can't put integers in string variables, and we can't put strings in integer variables. So we're good right here. But what we need to do next is we need to be able to get this value into an integer data type so that we can do math with it. Like I said, we're going to try and do some math with these numbers. So we're still going to need that n1, but what we're going to have to do now is we're going to have to convert that string into a number, right? So what we've done so far is we've created a Bufferedreader object that says, okay, we're going to use this thing. We don't care how it works, but it's going to allow us to get input from the user. We told the user what we're looking for. We captured whatever the user typed and we stored it in a string variable called S1. We then took S1 and we converted it to a number and stored it into a variable called N1. All right, so that's our first number. We have our first number. If we want to test to make sure this is working properly, we can just drop a print statement in here for a second, and just print N1 and just see what we get when we run through this. I recommend that you do this all the time. If you're not sure if you have this perfectly correct, the best way to do it is to just add a temporary print statement, just run it and take a look and see what you get. What I would expect to get here is whatever the user types to be echoed back to me immediately. Now, we won't be able to tell that it's a string or a number, but that's okay at this point. We don't really care. We're not trying to test that. We're just trying to make sure that whatever's stored in N1 is the number that the user typed. Okay, so if I run this, I can type any number that I want to, right? And it's just going to echo it back to me, right? So we need to do this again. We need to get a second number as well. So we'll say system.out.println, please enter a second number. And actually, I'm going to do print instead of print line. Now this time, if I say I want to get N2, right? Number 2 equals n.read line. This is going to give us problems, right? Oops, well that's a different kind of problem. This is going to give us some problems, right? The same reason as before. This is a string. We're trying to store it into a variable that we've declared as an int. Now up here we created a separate variable called s1. We temporarily stored that value in there that the user types in the s1 value, and then we parsed s1 and stored the resultant integer version of that variable in n1. Now we're never going to use s1 again after we do this, so it's kind of a waste to declare it and to set it up. So what we can do is we can just use this sort of in a shorter way. This is a string. Right? This is a string. As long as what we put inside the parentheses of this method call, this parseInt method call, we're perfectly good. So we don't need to create another variable. We can simply do integer.parseInt and put the parens around it. These two approaches, right? This one and this one do exactly the same thing. If we print N2, it's just going to echo back whatever number version of whatever we type is, right? So enter a number. If I type 100, now we're entering a second number. So we're at this point in our code. So our program flow, if you will, is sitting right here waiting for me to do something or waiting for the user to do something. And if I type 50, it can proceed. And basically before it moves on, it's taking this string version of 50 that I just typed. It's parsing it to an integer. It's storing it in variable N2. And then we're printing whatever stored in variable N2, which incidentally is 50, right? And then now we're at the end of sort of what we were trying to accomplish. Now we can simply print the result of N1 plus N2. So if we do that and we give it some numbers, 150, you'll see that we get the resultant sum of 150. So N1 held the value, integer value of 100. N2, we stored the integer value of 50. And then down here, all we're doing is simply printing the sum of the two numbers. Now, what do you think will happen if we type in bad input? And by bad input, okay, 100's good. What if we type ABC? There's nothing that's going to prevent us from doing that, but you're going to see that something goes wrong, right? We don't ever get the correct value. We don't get the correct result. The reason that we didn't even get an error message is because we already had this inside of a try-catch block, which is fine, other than if we go down here and we say we wanted to print the error. Get message is what it is in Java. Right? If we run this again and we try and see what we get. So if I do 100 and I do ABC, it says that it's having problems handling whatever is stored in ABC, right? If we didn't have this inside of a try-catch block, for instance, suppose we did it the original way that I showed you guys, and I'm just going to undo this temporarily just to show you. If I got rid of all my catch stuff and all my try stuff, if we don't have that, if you recall, we have to put that throws IO exception up here. But if we don't do that, if we don't have that inside of a try-catch block, when it runs into this problem of having bad input, it'll look a lot less graceful. It'll just explode pretty much, right? ABC. So now we're getting sort of the full stack trace of what went wrong. And basically it's saying Java lang number format exception for input string ABC. This is telling you that, hey, I'm trying to convert ABC to a number and I can't do it. And so what we need to do, I'm going to put my try catches back. So I'm just going to undo what I just typed. So put it all back the way it was, right? What we need to do is we need to basically check and make sure that the user is giving us good input. If the user doesn't give us good input, then we can't continue on with the program, right? We can't do the math. You can have nested try catch blocks. That's perfectly acceptable. Now, the place that you want to have nested try catch blocks are, in this case, around anywhere that something could possibly go wrong. So if the user types in something that's not a number here, that could create a problem. If the user types in something that's not a number here, that could also create a problem, right? Now, there's one other area where it could create a problem. If we catch both of these gracefully, and the user doesn't type some sort of number, we need to make sure that both of these values have numbers in them, right? So let's go through this really quickly, really simply. The try catch block is the same. So if we try to do this process, if we try to do this, and I'm just kind of inserting the stuff in here, right? Again, you can have exception. You're not going to be able to use E anymore because E is already defined. We already have an E. So we'll say E1. Right? What we need to do, if something goes wrong here, we need to basically print something that says something went wrong, or you didn't input a number. Right? We need to do the exact same thing down here. Right? So I'm going to just copy and paste here. And then I'm going to put my try up here as well. Got to be right here in front. So this is the end of a try. This is the end of a catch. This is the end of a try. And end of a catch. Oops, that's the beginning of a try. Right. So our code now looks a little bit more stringy. It's a little bit tougher to see what's going on here. So, but what we have is, let me clear it up a little bit. Right, so this is the first one, the first try. And this is the second, right? And you know, what we can do is we can move these inside of here just to make it a little bit easier to see what's going on exactly. And I'll do the same thing down here. Oops. All right. All right, so we have basically two try-catch blocks. Right, really three, right? This try-catch block out way outside is basically covering us in case something goes wrong from getting input from the user. Not in the same sense of parsing the string values to numbers, but just in case something fails along that process. It's just a requirement. If we don't do that, if we don't do that, then we have to add that throws IO exception up here, which is okay too, I suppose. But if something does go wrong, your program's not going to handle it gracefully. The next thing we do is we create a Bufferedreader object, which is what we're going to use to get input from the user. We give the user instructions, so we can move this inside of our try block as well, just to make it simple. We then are going to try to do this. We're going to try and tell the user to give us an integer value. We're going to take whatever they type, and we're going to store it in a string variable. And then the tricky part is this part, right? This is where something could actually go wrong. And what we can do is we're going to say if something goes wrong, if they don't give us an integer and we can't parse it to a number, whatever they typed, then we're going to drop down into our catch block and we're going to basically say, hey, something went wrong. And we're going to repeat that as well for the second time, right? We're going to say, hey, please give us a second number. We're going to try and convert that number into an integer value. If something goes wrong during that conversion process, we're going to print an error message right here. Now, we haven't talked about this yet, but there's this idea of scope, variable scope, in terms of inside different code blocks or subcode blocks inside your programming. There's this notion of scope where certain things can see other things. I'm not going to go deep into that right now, but what I'm going to do to fix this, if you run into this, is just remember that if you declare something inside of a code block for now, it can only be seen inside that code block. So we declared N1 right here inside of our try-catch block, which means that outside of it, it doesn't know what N1 is. Okay? This is why I said in class, oftentimes you really want to try to declare your variables outside or at the top or up front. So what I'm going to do now is I'm going to go back to my main method, inside my main method. So I'm outside of my try-catch block, right? but I'm inside my main method. I'm going to add a carriage return, and I'm going to go ahead and declare n1 and just set it to 0, and n2 and also set it to 0. Okay. Now what this is going to do, this is yelling at me saying variable n1 has already been defined. We've already created variable n1. So, which is what we just did and what we did on purpose, right? So now we don't need to declare this again. We just need to use it. So if we remove that blue data type, we're no longer declaring it. Now we're just simply using a variable that we've already created, right? So basically we have two variables, n1 and n2, that we've declared up here. We've initialized them to 0. And then what we've done is we have two separate try-catch blocks. One is designed to simply get input from the user for the first number. The second is essentially the same thing. You could have copied and pasted, and we're getting the values from the second user. Now, if we run this, we should see a little bit different handling of the problem, right? So if we type 50, put down here, or if we type 100, and then we type 50, we're going to get 150, right? No problems at all. Everything that we did was perfectly good, right? We were able to convert 100, the string version of 100 to a number, and we were also able to convert the string number of 50 to another number. If we run this again and we give it bad input, say we type 100, and then we type ABC, something went wrong, you didn't input a number, and we're going to not get the total value, right? We're not going to get 150 or anything else. We're going to get just 100, because 100 plus ABC doesn't make sense. So we initialized our variables up here to 0, so we're not going to add anything to the number, right? So what's going to happen? When this happens, everything goes well here, right? Because we actually did type a number, an integer number. When we come down to the second try-catch block where we typed ABC, when we get to this line right here, we're going to get ABC. We're going to try and parse this into a number. We're not going to be able to parse ABC into a number. So what happens is immediately when something fails, we're going to drop out of this try block, and we're going to land in this catch block, and we're going to print something went wrong. Because it failed right here, this piece of the code never gets executed, right? Nothing ever changes in n2. n2 doesn't ever get overwritten. So whatever value was previously in n2 before this failed is still going to be there. What value was n2 was this value of 0, right? This is why when we get down here, n1, which has the value of 100 in it, and n2, which because this failed converting ABC into a number, it still has the value of 0 in it. And so when we do the math, we get 100 plus 0, which means we get 0. You're going to do something very similar to this in your assignment this week. If you have any questions with that, or if you need more explanation, or if this is not clear, you can send me an email or let me know, and I'll try and help you out. But the trick is using these try-catch blocks in smart places and in smart ways, such that you're able to handle or control what your program does when you're getting input from the user. Users never give you what you expect. They often test your program, and they'll test your logic and see, accidentally, not necessarily on purpose, but they'll accidentally test your program. And if you're not able to handle their input, if your program isn't built to handle their input, then your application will crash or fail suddenly, and not give them any idea of what went wrong or why it went wrong. So it's really good that when you catch your exceptions, you provide input or feedback to the user as to why something went wrong. In this case, it's, hey, you didn't give me what I was looking for. All right. So again, review this, take a look, do the practice problems on Blackboard, and let me know if you run into any problems or if you have any questions.